Hello everyone, I am Dr. Godanda Raman. In this section, we are going to discuss with short question and answer unit 4 game theory and inventory model. See the question. Define players. There are two players in a game. The players may be any two companies. For example, company A and company B competing for tender. So two countries planning for trade gain in a third country, and team A, team B participate any type of game. So these are the players. Define strategy. A strategy is a complete plan of action a player uses during a game. It can be pure or mixed. For example, the any company giving computer hardware, selling computer hardware, during that time computer furniture free of cost, giving additional hardware, giving special price. These are some strategy they are following selling computer hardware. So this is a following some strategy. Pure strategy. Define pure strategy. If a player select a particular strategy with a probability of 1, then the strategy is known as a pure strategy. This means that the player is selecting that particular strategy alone, ignoring his remaining strategy. If player A follow pure strategy, then only one of the pi values will be equal to 1, and then remaining pi value will be equal to 0. So this is the only we are going to follow. For example, suppose a sample probability we just connected p1 0, p2 1, p3 0. So only 1. So the probability 1 or 0. So this is the only one, p2 1, other strategy 0. So only one strategy, it's a following. Define mixed strategy. If a player follows more than one strategy, then the player is said to follow a mixed strategy. But the probability of selection of individual strategy will be less than 1, and their sum will be equal to 1. So this is a mixed strategy cases. So suppose p1 value 0.5, p2 value 0.3, p3 value 0.2. So the total probability value should be 1. So sum of the probability equal to 1. This is a consider mixed strategy. So p1 plus p2 plus p3 1. So just count this, the total value 1. Saddle point. Define saddle point. A saddle point is the element in a payoff matrix that is minimum in its row and maximum in its column. It indicates pure strategy solution. It's normally maximin equal to minimax. So this is our saddle point. And define dominance property. So dominance property is nothing but dominance property allows elimination of dominated row or column in a payoff matrix when one strategy is always better than the another strategy. So we are following dominance property. So when the dominance property possible to apply when it's no saddle point, because max min max not equal when it's no saddle point, and then we are going to follow when it's not mixed strategy condition. If 2 cross 2 is not there, then we are going to apply with this strategy dominance property to reduce more number of row and column when we have to reduce using dominance property to reduce 2 cross 2. So this is a main focus, we are using dominance property. Define value of the game. The value of the game is expected payoff matrix when both players use their optimal strategy in a game. So maximin equal to min max is a saddle point. So the saddle point value is nothing but value of the game. If max min value, min max value equal, then the saddle point we have some value. The value is the value of the game. So define max min principle. So the principle maximum. So the maximum principle involves selecting the strategy with the maximum of the minimum payoff matrix to ensure safety against the worst case. So the principle maximize the minimum guarantee gain of player A. The minimum gain with respect to the different alternative of A irrespective of B alternative or the corresponding alternative called maximum strategy. Suppose mini-max principle, the principle minimize the maximum losses with respect to the different alternative of player B irrespective player A alternatives or obtain first. The minimum of these maximum losses is known as mini-max value. So this is a we are going to follow. Now the write various deterministic model in inventory. So various deterministic means we have to consider two type of model we are following: manufacturing, purchasing. So manufacturing with strategy and manufacturing with shortage, manufacturing without shortage, and purchasing with the shortage, purchasing without shortage. So these are the various deterministic model in inventory model. So define economic order quantity. So the economic order quantity is nothing but, so EOQ is the order quantity that minimize total inventory cost. So total inventory cost is nothing but ordering cost plus holding cost. So this is sometimes the question is very short form, define EOQ or define economic order quantity. Then we can use this question. EOQ is nothing but, so very simple answer, the order size which the total cost is minimum. So this is a economic order quantity, or sometimes we use optimal order size. This is also possible. And some other type of question possible, cost of inventory system. Cost of inventory system. So what are the cost possibilities? Purchasing price, and then ordering cost, purchase cost, ordering cost, carrying cost, and then shortage cost. So these are the possible some few short question and answer. Thank you.